I'm Jamie Rawson. I'm a senior instructor for VMware, and we're here to talk today about troubleshooting in the vSphere 6 environment. Thank you very much for coming today. Nice to see so many folks and a few familiar faces that I've had in classes in the past. Thank you. Today we're going to be addressing vSphere 6 troubleshooting. We're going to take a look at a little bit of an overview of the troubleshooting process and then getting into some specifics. Naturally, in the course of an hour, we aren't going to exhaust the topic of troubleshooting, but we do want to touch upon some of the key points, and particularly some 6.0 issues you'll want to be aware of. Just a couple of things, a course disclaimer here. After the conference, you'll have access to this slide deck, and this slide deck includes actually a number of slides that we're not going to actually present here today, simply for reference material about some specific issues with upgrades and installations of 6.0. That would be kind of tedious to go through in a slide presentation anyway, but they're in the deck so that they're part of what you can take away from this. Just a couple of, I'm going to bypass these because you've probably seen these at some other sessions and get right into our presentation. We're going to be taking a look here, as I said, a little bit about the general principles of troubleshooting, just as a starting point, and then we are going to be taking a look into some aspects of the command line interface. Again, not a terribly deep dive, but some important tools that are available to us there. We will take a look specifically at troubleshooting a couple of different aspects of our network. We're going to be taking a look at the storage and our clusters with HA and particularly vMotion as the cornerstone of our DRS capabilities. The material that we're going to be covering here is very significantly drawn from our troubleshooting workshop class, which is a 5-day hands-on troubleshooting practice, which is a little bit different than our traditional instructor-led classes that are more of a procedural approach, where the labs are somewhat of a cookbook type approach. We have actually hands-on where you install a problem through a scripted installation that you'll then have to identify and resolve. And that makes for a very good way to learn troubleshooting because you get the benefit of an unknown problem to have to identify and resolve without the stress of troubleshooting in live fire exercise. The 6.0 troubleshooting workshop is currently under development. You will not find it presently on our schedule, but we do have in the fast track class, we have some components of the troubleshooting incorporated into the fast track class, which is a more accelerated approach, 10-hour day class for the vSphere 6 environment. A little bit about troubleshooting in a general way. It's probably pretty obvious we're going to need to troubleshoot when we encounter a system problem. It makes sense then that we have a fair idea of the general definition of a system problem, something that prevents us from using the system the way we need to use it, and have some general idea of causes, such things as component failures, hardware failures, specific software failures or bugs, but also things such as administrator misconfiguration, perhaps even deliberate attacks. And when we are looking at these different issues, perhaps the most frequently encountered is resource contention. When we're looking at overuse of our resources, oversubscription, creating performance problems. Now in our presentation today, we're not going to concentrate at all on performance, simply because that's a sufficiently large topic to require more than we can fit into here. But performance is also a very important part of our troubleshooting toolkit. And just as a note, we do cover that in our Optimize and Scale course, which is currently available for 6.0. The other two aspects I mentioned here beyond usability and performance, the accuracy and reliability, are oftentimes thought to go very closely together so that they're almost treated as one, but they are slightly different. And we can have problems that could create issues with the reliability of our data or the accuracy of the measurements that we're taking. In the troubleshooting process, we basically start off with defining the problem. This may be because someone calls you up and simply says, hey, it's not working, or some other helpful tip like that, or it may be something very specifically that you've encountered. But knowing exactly what the problem's symptoms are is going to be the place where we start. And of course, a great many symptoms themselves don't necessarily give us enough information to propose a solution just from the symptoms we're seeing. Suppose a user working on a virtual machine desktop reports that they can't get to the internet. Well, that's certainly a definite problem to resolve, but we'd have to do a bit of research and a little bit of verification before we can narrow down the actual location of the problem. So we need to gather information. Evaluating our information, we're going to then identify the cause of the problem, which is very often a process of elimination, rather like a classic detective mystery, where you have possible suspects that you test and eliminate until we narrow it down to the cause. And finally, resolving the problem. When we are looking at solutions, one of the terms that we use is, the best solution, but best is really surprisingly a relative thing. There may be solutions that quite simply would be the most desirable long-range solution that you just simply cannot put into practice under your current circumstances. Maybe a failed component needs to be replaced, but the shipment's not going to arrive till tomorrow. Or other situations that require you to instead adopt a workaround or a temporary solution. When gathering information about the problem, we start off with verifying that the problem exists, really. See if we can reproduce the problem. We can spend a lot of time spinning our wheels pointlessly if we're trying to solve a problem that actually doesn't exist. Maybe that user who couldn't get to the internet just experienced a momentary delay, and when we test it out again, we have no problem. The next thing we need to do is identify the scope of the problem. And this is going to be essential for determining where we will begin to look for our expected source of the problem. And once again, I'll use that example of a troublesome virtual machine network connection, because one of the things I need to ask is, do I have other virtual machines that are experiencing that problem? Is it limited to just one virtual machine? Is it limited to just one website, I suppose, would be an important question. But when I am looking at the scope of the problem, if I find that multiple virtual machines are affected, perhaps they share a common port group or a common switch, maybe an indication of underlying hardware failure, whether at the host interface or at my underlying network fabric. Then we'd need to gather additional information. One of the crucial questions, which I think anyone who troubleshoots any system tends to ask without even thinking about it, is, was it working before? If so, what have we done to change in the meantime? And that's going to give us a very important area to look to. When we're looking at a system that was previously functioning, some change must have occurred for it to be malfunctioning. If we can track that down, that may give us the dead-on point that we need to take a look to. Reference material, of course, some things such as product release notes, online reference manuals and documentation, and also very helpful may be the various discussion forums that are available, especially when you have problems of configurations that may be rather specific and fairly unique to your environment. It can be very good to be able to discuss with others in the user community who may have had similar or even the same problem. And then finally, the last point we make here in the general process is knowing the environment you're working in. And that's going to be either by your own experience from the environment that you've been working in for some time, or if you're dropped right into a brand new environment and told, fix this, you may need to rely on site documentation. Knowing how the site is correctly configured is going to be essential to identifying what may be incorrectly configured. And by the way, in the absence of a good set of site documentation, the other very valuable tool would be if you have access to systems that are working correctly, that you can compare the configuration of the working systems to the non-working system, serving as a form of site documentation. Now here I'm going to sound like I'm being almost a bit sarcastic, but it's actually important to read error messages. And I say this being oftentimes myself guilty of, oh, it didn't work, let me go back and look at what I did rather than reading the error message for a little more assistance. And that's because historically error messages were not necessarily terribly informative. And the reason they weren't made sense back in the days when 4K was a lot of RAM, but it probably hasn't made sense for a long time now. I'm very pleased that one of the initiatives in the industry for a number of years has been to make actually useful, meaningful, applicable error messages. And we're not alone in this, and I'm not sure that we're perfect in this, but one of the things I'm very pleased by is more and more detail available in the error messages that can help us resolve a problem. So I suspect you probably can't read what's actually on the screen before you here, but what we're looking at here is an error message where, when powering on a virtual machine, we get a message about insufficient space on the device, and when I look at more details of the error message, I'm going to find that it's unable to create the file for the swap file for the virtual machine. Now here's a good case to ask what's changed, because presumably this virtual machine had been working previously. Something has changed that I'm now unable to power it up. Maybe someone took some snapshots or created some new virtual machines or otherwise consumed disk space. And then looking at my solutions. My ideal solution might be to expand the size of the data store, but I may not be able to put that in practice right now because of resource limitations. So then perhaps the best thing to do would be to migrate some virtual machines to other locations, free up some space by cleaning up old snapshots, or possibly even taking the approach of increasing the reservation for memory of the virtual machine, thereby correspondingly decreasing the size of the swap file. So we do have some different options, even once we know exactly what the problem might be. When we are looking at tackling a troubleshooting problem, just a quick reminder about being methodical as you approach the problem. This is one of the essential things which makes troubleshooting possible. And some folks have a reputation of being natural-born troubleshooters. But no one was born troubleshooting a vSphere environment, I'm quite sure. The experience you bring to it, of course, is an essential component, but approaching in a structured fashion, it does not have to be rigidly structured, but in a structured, logical fashion is going to be essential to troubleshooting any environment, as I'm fond of saying, whether it's a broken toaster or a broken data center. And when we're looking at this approach, we have a couple of different approaches that can make sense depending on what scope of the problem we have identified. We refer to these as top-down and bottom-up. That's a bit of a shorthand. Top-down, meaning that we are looking at the most specific component as our starting point, and then moving our way through the various elements down to the most general components. Case in point, suppose I have a virtual machine that isn't able to reach the internet. I might want to look at settings within the guest operating system, settings of the virtual machine's network hardware, settings of the port group and virtual switch, possibly the physical NIC on the host, possibly my physical ports on my physical switch, and so forth. I'm moving from the most specific component to the most general, and that's what we mean by top-down. For the bottom-up approach, just simply the other direction, maybe I've had an all paths down condition, a failure at my storage. Makes sense to start with my storage, which is going to have a more general impact affecting multiple hosts, multiple virtual machines. So that would suggest a top-up approach. In specialized cases, we may have a good opportunity to use an approach that if anyone here ever had to do diagnostics on printed circuit boards where you had to identify where there was a failure in the circuitry, you probably don't just put the test at the source and destination connections of the circuit. You would approach it by halves, generally speaking. Not necessarily literally 50%, but put your test somewhere in the middle and look to see, can I get a signal to the left-hand side? Can I get a signal to the right-hand side? And this kind of approach allows us to more quickly narrow down to where the actual failed connection is. And that kind of logic may serve us well, especially when we're looking at the components of our environment that are analogous to circuitry, such as our network. We may have a host that can communicate to some hosts on one direction but not in another, and allow us to approach it in this kind of halves approach. And then resolving the problem, depending on the impact of the problem, that's going to give us a very good measure of what kinds of effort and what kind of potential disruption I can tolerate in order to be resolving my problem. In some cases, problems can be resolved without really any interruption at all. Others may require a host reboot, and so forth. And then, as I said previously, our solution may be an ideal long-range solution we can leave in place for an extended period of time, or we may be constrained to work with some sort of less than ideal, more short-term workaround. For example, if I have determined that my problem is due to resource contention, I have not gotten enough resource within my cluster, perhaps my ideal solution is I'm going to add a couple of hosts to the cluster to increase overall cluster resources, but that's going to take a couple of days to get that all in place. In the meantime, I might adjust the priority of my virtual machines using my resource controls, which kind of pushes the problem off to some other less favored virtual machines, but would allow me to at least address the current situation. And so just as a little kind of mini case study, we have an example where when attempting to migrate a virtual machine from one host to another, we've gotten a timeout after about 60 or 70 seconds that the virtual machine migration fails. Now, a couple of things to know about this. The error message will be a good starting point, but before we even look at the error message, our knowledge that the virtual machine migration was attempted is going to be a very good starting point, because the fact is that there are a number of possible reasons that vMotion might not work that I can eliminate by the fact that I was successfully able to launch it. For example, the pre-check that is performed for vMotion will look to see such things as that there is an interface identified for vMotion on both hosts, that we do have virtual machine resources that are not dependent upon a specific single host, and so forth. So knowing that we are able to migrate, the error message was going to be a very informative, or I should say potentially very informative at least, to tell us where to begin looking in further detail. Because we launched the migration successfully, it'll be helpful to know that vMotion in its pre-testing does not actually send an active communication over the vMotion network itself. This means that while the pre-check has passed, I don't know about the integrity of my physical communication for moving the actual bulk vMotion data. So that means I'm really likeliest to focus on that part of the configuration. And in the error stack here, again, I'm doubting that you can read it, but it's telling me that the communication failed between two IP addresses, one of which has the number 12 in the third octet, and one of which has the number 13 in the third octet. Although I can't definitively, just from this data alone, determine whether that's an error configuration or not, I'm suspicious that it probably would be, and if I look and see that this is using a typically flat vMotion network with a typical Class C style net mask, I might find that to be an error to investigate for a possibility, and either look at my site documentation or look at a couple of hosts that I was able to successfully migrate to see what the settings actually should be. Now, when looking at the causes, because of that interface mismatch, or I should say the address mismatch, I have a strong suspicion that it's probably a simple misconfiguration that can be pretty quickly and painlessly corrected. But it is also possible that the problem may additionally include disconnectivity of our physical medium as well. So even though I think I know what the problem is, I do want to be methodical about my testing and evaluation to make sure that I'm not overlooking other possibilities. And we offer a flow chart here, which I'll not go into the full details of, but basically, again, being methodical, testing each of the components, including if we can reach the other host's management address, as well as reaching its vMotion address. And a good old ping is a pretty good starting point to test. When we look at the impact of this particular problem, this is one that we can pretty easily fix without any negative impact, because as long as the interface is misassigned, be able to use it anyway, so it's not like I'm going to be interrupting anything in the middle of stuff. So I can probably fix that pretty much at my leisure or immediately and get up and running again. So one of the things I wanted to talk about today in particular is a bit about the command line environment. And the command line environment in our 6.0 is still one of our really valuable tools for troubleshooting purposes. Command line environments have traditionally had a bit of a reputation of being cryptic and difficult, and I don't have any argument with that, although I think it's a matter of a certain amount of subjectivity. Command lines have traditionally been fairly cryptic for a number of legitimate reasons, and that makes them not necessarily the most convenient thing to learn because they're rather code-like. But the other thing is that command lines sometimes have a reputation of being more powerful than graphical interfaces, which doesn't necessarily ring true in the modern world. Our GUI interfaces are as powerful or more so quite often than what we can do from the command line. So the reason we want to know the command line is primarily because it represents an alternative. It's not always a better choice for troubleshooting, but it is an alternative from the graphical interface, and it can be extremely valuable in cases where I don't have access to the graphical interface, such as if I lose communication to my management interface. If I lose the management interface, I'm likely going to have to go to address the console of the machine and log in through either a menu interface for some testing or go to the command line for identification and resolution of the problem. So we're going to be taking a look at some of the commands that are available to us, just briefly, but we're going to take a look at the ESXi command, which has been one of my favorite commands since it was introduced, because I'm an old command line hack from way back when that was the only choice that existed, and I really like the command line. But I like this ESXi command because it represents what we can honestly use the buzz phrase from about a decade ago that was so popular for a while, the paradigm shift, if you remember that one. Well, this ESXi is really a paradigm shift in the design of the command line interface. We're also going to look at commands that are available for the ESX config commands, and look at how these can be used for troubleshooting, particularly in the data gathering phase of things. Now, this is what the command line interface offers us when we directly connect to the ESXi host. We do also have the command line interface toolkit, which may be of interest and use as well. The command line interface toolkit, which is actually an installable package for either a Windows or a Linux platform, is quite commonly implemented as part of the vSphere Management Assistant, which is a Linux-based virtual appliance. The vSphere Management Assistant gives us many of the same sorts of tools, but from the command line interface package, the command line interface tools that are equivalent to the ESXCFG commands are going to be prefixed with VICFG. Now, when we want to access the ESXi shell, we can do this by directly addressing the console, either physically sitting down before a console, or perhaps in this day and age, more likely, having a connection through some sort of network-based connection that allows you remote access to a console, like a Dell Remote Access Console or Integrated Lights Out from HP or one of those sorts of tools. We also have the possibility of accessing our command line through an SSH connection. It's worth noting that the ESXi host, as it is distributed, has both of these access points disabled, just from the general point of view of security. Building with fewer doors and windows is easier to secure. A host with fewer remote access points is easier to secure. So by default, both the interactive shell from the console and the secure shell server are disabled, and we have to explicitly enable those, which can be done through either of our graphical interfaces, or it can be done through the menu interface when you directly address the console. The Management Assistant is a virtual appliance that runs on a Linux platform and gives us a full command line set of tools that allow us to do remote administration in our environment. And these tools are going to be equipped with an authentication component specifying which host, user, and password we're using to authenticate. And that can make them a little cumbersome because of the multiple iterations of authentication. So we do also have a fast pass feature, a way to cache the credentials during our active sessions so that the user doesn't have to repetitively enter in the same information. I mentioned that I'm particularly fond of the ESXi command because it represents a very big new direction in command line development. It's not such a new direction in software development in some ways because the logic of it is really quite distinctly in line with the logic of the design of a graphical user interface. What I mean by that is, a little hard to see the connection when you're thinking about graphics, but we have, instead of tabs and panels and things such as that, when you execute the ESXi command, we have different areas of system focus that we refer to using the term namespace, borrowed directly from the domain name service, gives us the same kind of compartmental hierarchical organization that really underlies our graphical interface design as well. And the reason that I think this has a big benefit to us as administrators is because very often administrators are not necessarily going to sit there and read all the documentation before trying out a command and such. And with our more traditional command line tools, that can be a little bit frustrating because the online diagnostics and help available on a given tool aren't necessarily terribly verbose. But with the ESXi command, because of its hierarchical organization, it's much more suitable to learning the way you might learn about a typical graphical user interface, where you launch it and you start looking at things and you explore. And in the case of these different namespaces, if I type the ESXi command all by itself, I'll see the first hierarchy of namespaces. When I type in additional information, such as ESXi network, I can see the namespaces that are specific to the network. And I can drill down. If I wanted to say, just give everyone here an access to this tool and ask you to tell me how you would find out what the status of your NICs would be, I think that anyone who has any experience with the graphical interface would quickly drill down and find this information, because you can just simply keep on looking further and further and then see examples. And I'm not going to say that it's an entirely self-tutorial approach, but it sure is a whole lot more administrator friendly than the traditional command line. And so just to build on this, ESXi network vSwitch would then show you had the listing of either the standard or DVS vSwitches, network vSwitch, standard, look at the options you have for the standard vSwitch, and then you'll see there's functions like add or remove and other things. So it makes it a lot easier, I think, to navigate through the command line interface, much like you might do when learning a new GUI. Also, I did not incorporate all of the details, but there are a number of new features to the ESXi command that have been added in the 6.0 release, including support for specific functions such as vSAN and vVols and other features that we incorporate into the 6.0 release now. The VICFG commands, these are available through the command line interface toolkit. The equivalent, when we log directly into the ESXi host, begin with the prefix ESXCFG. The difference between the two is that these commands with the VICFG prefix have the authentication triplet, the server username password authentication feature built into them, so that they can be used for a reliable, secure remote connection to your destination host or vCenter. What is maybe a little more complex about learning these is this is really a number of different commands, each with their own special focus, instead of being under the hierarchical umbrella approach that the graphical interface and that the ESXi command use. For managing virtual machines, we have a variety of options we can include with our vmware-cmd command. This will allow us to do such things as power on virtual machines, power off virtual machines, check the status if they have snapshots and other things, get other information that you might want to use as conditional decision making in scripted solutions for managing virtual machines. All kinds of neat stuff, although we don't actually have the ability to create or destroy virtual machines with this tool. When we want to find out what virtual machines are currently registered, we can use the vmware-cmd command with the -l option. And this becomes useful because when you are identifying individual virtual machines to manipulate with this command, the identifier is going to be the very long, fully qualified path name to each virtual machine's individual config file, the .vmx file. That identifier makes perfect sense as a unique individual identifier, unambiguous. It's not necessarily so interactively operator friendly. Cut and paste will be your friend on something like this, I suspect. When we are troubleshooting, information recorded in log files is going to be one of our very potentially valuable resources and something to take a look to, especially when I'm not quite sure where to begin looking for a problem. And we have several logs on the ESXi host that would be typically useful. There are more log files than just what we've delineated here. The reason that these are listed is because they are among the most typically helpful, and the other logs are located in that same directory on the ESXi host under /var/log. There are other logs that may be potentially useful as well. If you've worked with command line tools like grep or other tools for looking through a number of files, that can be a handy way to look through a large number of log files. But typically, the first two listed here are probably going to be the ones that I would say are the go-to files to look to. These are all plain text files. Any text tools that you're familiar with would be suitable for manipulating and viewing these files. One of the things that I rather like about the web interface is that we get a nicely formatted approach to the log files, because from the command line, they're not laid out in such a tidy columnar fashion. And I think that the columnar display makes these really very nice to look through. And also, we do have a search filter here so that when you are looking through a very large log file, you don't have to just eyeball through thousands of lines of sometimes pretty cryptic output. One of the things that I think is a very nice aspect of our 6.x environment is the audit trail for administrative tasks has been improved. Prior to our 6.0 release, up through the 5.x environment, the administrative functions were always logged as attributed to VPX user. The only challenge with that is that it meant that if we had a couple of qualified administrators, it was sometimes a bit difficult, unless we're really careful to look at logins and logouts and such, sometimes difficult to know which actual user to attribute it to. In the 6.x environment, we get an actual association of which user is executing with that authority. So that can be very helpful for troubleshooting purposes, as well as possibly other kinds of audit trail purposes. With the console interface, we can get to the log files through one of our menu choices. When we log into the menu and we go to the system logs, we can just specify which log we want to take a look at by number. And then we're going to be viewing a paginated, essentially a command line view of our log files. The 6.0 log files for the vCenter, located under the all user profile path I mentioned here. And for the appliance version, they follow the Linux convention of var log as the location for the log files. One of the things that you may be asked to do, particularly if you're working in conjunction with technical support to resolve an issue, is to create a log bundle and send that off to technical support for further analysis. And we can do this through our command line tools or through the graphical interface, depending on what our preference is. In the GUI, when I say the GUI, there's of course still two. Either one of the GUIs can be used to generate the log bundles, or we can use the command line script called vm-support. A little bit about network troubleshooting. When we're looking at network troubleshooting, one of the reasons that this is an area that's just rich with troubleshooting opportunities is because we have components beginning with the guest operating system configuration for networking, its stack, its network interface, configurations like the usual suspects of IP address and net mask and possibly VLAN ID, possibly the choice of our network interface for the virtual machine, moving through to settings on the port group, settings on the virtual switch, down to the physical components of our network. In this example here, we're talking about a network issue, which I think is worth pointing out because it's a case where we have intermittent connectivity to a host that we have successfully added to our vCenter server inventory, but which after 30 to 60 seconds, maybe a little bit longer, will show up in a disconnected state. Now here we have one of those challenging situations that arises when it's working at the initial point, but then it stops working, which can make it a little bit of a mystery to track down sometimes. And here's a case which illustrates also a potential limit with a useful utility like ping. I may still be able to ping the host and not connect to it from vCenter. And here it's helpful to note the vCenter is establishing the connected state by monitoring a heartbeat on port 902. And this intermittent disconnect, I go back and I reconnect the host successfully, but it goes to a disconnected state again. Clearly, I do not have an issue with actual network communication itself. The fabric of the network is working properly. Something else is interfering with my communication. And one of the usual suspects here would be a host-based firewall on vCenter itself. If we simply engage a host-based firewall on vCenter, very typically those host-based firewalls are not going to know about the required ports for vCenter, and therefore would block ports like the heartbeat port of 902. A couple of features to know about. These are not new to the 6.0 environment, but are worth mentioning in the troubleshooting context because they give us some protection against some of the more frustrating and perhaps easily avoidable problems that we might have to troubleshoot. Anyone here ever make a typo on an IP address or a net mask or something like that on a management interface and disconnect, and it's like, oh shucky darn, now I have to drive into the office or something. We've got this feature of rollback, which is implemented through the web client, and it is implemented by default. You do have the ability to turn it off by setting an advanced kernel parameter variable to a false status, but it's there by default, and it's kind of like a nanny watching over the kids, because if I make a mistake that's going to cause me to disconnect, it will actually not put that in place, it will put the previous working configuration back in place. You will get an error message that tells you that your configuration would have disconnected and that the previous configuration has been restored. But it's pretty nice because I almost never want to make a forcible disconnect for a situation like that, so it's a good thing to have by default. We have a similar capability with the distributed switch. The distributed switch gives us this capability for such things as changes like changing the MTU value that might cause disconnect from my virtual machines. That too would be detected and the original working configuration put back in place by this rollback facility. Again, this is enabled by default, can be disabled if you wish. If we have a misconfiguration, one of the things that we can do to help avoid that is to use the feature we have for a backup of the distributed switch. It's actually under the function labeled export, but what it allows us to do, and this again is through the web client, it allows us to capture the configuration of the distributed switch in a form suitable for restoration if we do have corruption or misconfiguration issues that are going to be fairly time-consuming to resolve. We can simply restore the previous configuration. And the other thing that's nice is I can export my configuration to another vCenter if I wish. Now, one of the areas we want to look to also is storage troubleshooting, and storage, of course, is another area rich with troubleshooting possibilities, including a number of possibilities that we're not really going to look into here that would be specific to diagnostics and identification of problems on specific storage hardware solutions. But what we're looking at here is what we can see from our vCenter ESXi host side of things. And one of the possibilities may be that we have a case where we're not seeing all of the LUNs presented to a host that we expect to see. Now we can use a command line tool like our ESXi command to list what LUNs are visible. Of course, if I'm just listing what's visible, how do I know what's not visible, right? I can see what I can see. This is obviously a case where I have to have either documentation or working configuration to compare to, or my personal experience with this environment. I'm seeing 3 LUNs, I know I should see 4, that kind of thing. When you have a case where you're not seeing LUNs, it may be very useful to go ahead and start with a rescan. It's kind of analogous in the storage world to doing a ping in our net communications world. The rescan may not resolve things, but it's actually possible it does, and it's a reasonably good place to start as a result. When we're looking at the output here, we give a couple of examples here of the ESXi command. I should note that there are also equivalent commands available to us from the VI config commands or the ESX config commands. I tend to have a strong preference for ESXi, so that's the one I give examples of. When we're looking at possible causes here, in a case where we have an error that is a more general impact, such as a report of all paths down or a permanent device loss, this is a case where a top-down approach or a bottom-up approach, either one might work pretty well, but since the condition really starts with the storage itself, a bottom-up approach seems to be a good way to tackle it. And if we verify that we have received this all paths down or permanent device loss status, we would need to use diagnostic tools at the storage side of things to identify what the underlying culprit is, but we would also need to address the impact on our ESXi host. And we've got a couple of ways to do that. One of the things to note, and this is specific to our 6.0 release, is that if you are using NFS 4.1, which is a newly supported, it's a version that we have added support for into the 6.0 environment along with version 3. There's an issue with an all paths down condition causing the virtual machines to remain in a halted state where we will actually have to reset the virtual machines. It's a manual resolution. And there is a detailing on this in the referenced KB article here. So this is a case where if we encounter a problem like this, kind of a shortcut to reading the release notes, we've got a known issue and it does require a manual administrator intervention even if you have resolved the all paths down condition. Now, another thing to note is that we may have a case where an all paths down condition is reported, but resolve before we reach that 140-second default timeout value. This is a known issue in 6.0 where we do have the counter continue to count down, the timer counter continue to count down, even though the all paths condition may no longer be present. And so we will still have the impact of an all paths down condition. This may be a case where we actually have to go to the step of rebooting the affected ESXi hosts. And again, reference in the KB article there. Another specific case is with a very specific implementation of storage. On the EMC VNX array, we may find that we have an inability to create files greater than a terabyte for a virtual machine, simply because that is an actual upper limit of file size on that particular array as it's currently implemented under its most recent firmware release. The Storage Views tab from our graphical interface is no longer present in our 6.0 release. This is actually by design. The interface for that information to be collected is not present in our 6.0 environment. However, we do have the equivalent information available. We do have a possible solution through a command line interface. That command line interface, in this case, being a PowerShell. The steps to gather that information are delineated in the KB article mentioned here as well. With the growth of the use of solid-state drives, one of the things we've reflected in the Esxcli command is the ability to query the status of solid-state devices specifically. With NFS, a couple of things to bear in mind about NFS. The NFS server can share volumes as read-only. If we're expecting to be read-write, we would need to make sure that we have the correct configuration. We also have the issue of possibly access control lists being restrictive. If I add a new host to a cluster, I may find that that host does not have access to the NFS server. Compatibility list for our NFS versions. There are a couple of features not yet fully integrated with the 4.1 NFS. And it's important to note for the access to NFS, the hosts should access either version 3 or 4.1, but not both simultaneously. This can create problems with the consistency of data because the locking mechanisms are very different between the two. Locking mechanisms on the 3.x implementation are host-based. They are server-based on the 4.1 implementation. They're not comparable to one another or compatible. So we need to make sure that we are using one or the other for a given host, or actually, for practical purposes, for a given cluster. And for NFS information, again, the ESXi command has been updated to give us detailed information from the command line interface that would be equivalent to what we can also view through our graphical interface. A couple of points about clusters. In the HA environment, probably the most commonly reported reason of misconfiguration or just not behaving as expected with HA comes from a misunderstanding or an incorrect selection of the admission control policies for virtual machines, reserving resources for failover purposes. When we see an issue of insufficient failover capacity, this could be for the cluster simply not having enough capacity currently under its workload. But one of the things to bear in mind is when we have set the admission control policies, which we typically do, the admission control policies are going to ensure that we have enough resource to be able to survive the number of host failures or whatever percentage we have set, and reserve capacity for that purpose that won't be available for virtual machines in their normal operating mode, and so it will be available when we do have a failure. One of the challenges here is that in the case particularly of the default policy, which is entitled number of host failures, it's not setting aside a percentage of resources, which many people quite intuitively but incorrectly think. It is setting aside resources based on what we call a slot size, a reservation of a certain amount of memory and CPU based on the largest reservation of any virtual machine running within the cluster by default. One of the nice things in our 6.0 environment, we have the ability to set a default slot size if we wish to use that through the graphical interface of our web client. And if we do have this case of insufficient resources, it would be a case where looking at the available physical resources of the cluster would be a good place to start. See if we do have virtual machines that have unusually sized reservations, because one of the symptoms that might be is everything's been running fine in the cluster. We power up a new virtual machine, suddenly we don't have sufficient failover capacity, and it turns out we've got a virtual machine with a much, much larger than average reservation of memory, and that could be the culprit right there. If we have the HA admission control policy configured incorrectly, we may be setting aside a larger than necessary percentage of resources. We may have set a fixed slot size, and we'd want to address that. When we have a failover for HA, the HA is going to take into account the virtual machine's reservation, not just for the host-based resources of CPU and memory, but also reservation for things such as our network I/O control bandwidth requirements, so that we have that as factored into our failover capacity in our 6.0 implementation. Another nice thing, HA is now smart enough to be able to respond in cases where we have an all paths down condition or permanent device loss failure in our storage, by being able to restart virtual machines that are affected by that failure on other hosts, if possible. So it's built a little more intelligence into some of the hardware conditions. vMotion in our current implementation is actually in its own IP stack, so it's separate and distinct kernel resources from other network communications. If we are using long-distance vMotion, which is now available in 6.0, we simply have to make sure that we meet the requirements, a maximum value for the return trip threshold. I think it's 150 milliseconds. But there are specific requirements, once again, outlined in the attached KB article here. And we have the ability to do vMotion migration between hosts. Oh, I went one too far. Between hosts, we can migrate to completely different, I said between hosts, which of course we can, that's been around for a while, between vCenters. But the vCenters are going to need to both be 6.0 vCenters. And an issue with vMotion, if vMotion is giving us problems, we may have a case where reboot ultimately might resolve the problem, but we might be able to take a little bit less drastic step of restarting the management agents, which we can do either through the command line interface or the DCUI menu. And one of the things that is kind of equivalent to rebooting, but it's just rebooting vMotion, if you will, is to disable and re-enable the Migrate.Enabled value in our VM kernel variables. This actually unloads the migration module, the vMotion migration module, and then restarts it. And just about the beginning of the year, I actually, for the first time ever, encountered the error, just like it says here, and I had a chance to say to my student who thought, oh my gosh, I've broken something, and they thought they'd done something wrong, and I said, kind of gleefully, no, this is great, let me try this. And it worked. So I'm glad to say that from personal experience, it actually did resolve my problem, and I didn't have to reboot the host, which was good. For DRS configuration, sometimes people are worried that DRS is not migrating as much as they think it should to balance things out. It may be simply that the opportunities to improve balance aren't there. If you have a cluster with some very large virtual machines and some small virtual machines, you might see kind of a nice even distribution. But if you have a lot of rather large resource-consuming virtual machines, there may never really be a case where you get something approaching a true balance, even though it is as well balanced as possible. So it may be that DRS never migrates because possibly we've left the migration level to manual. It may be that it seldom migrates because we do have a pretty stable environment. Or it may be that it migrates quite a bit because we have a lot of changes. What we really need to do is to keep track over time of what our migration patterns look like so that we can identify when things are perhaps unusual or unexpected. And that's where the history feature of our migrations is going to be helpful to us. Now, I do have several slides here that are designed as reference, and I'm not going to talk through them, but they are some known issues specifically related to upgrading and installing 6.0. And I wanted to include them here because the deck is going to be reference for you. Oh, they all build. I thought I was going to be a little slicker than that. In any case, just a couple of thoughts to wrap up here. For training and certification, one of the things that you may well be aware of, and if you are not yet aware of it, please visit us up on the 3rd floor in Moscone West. We have a number of new certification initiatives out there that you very well might be interested in. And we do have additional classes under development, so stay tuned. I see people are leaving, but before we wrap up, I'm happy to take any questions. There are a couple of microphones about middle of the room there, that if anyone has a question to ask. Otherwise, thank you very much for coming today. I certainly appreciate it.